Hello, today we are going to complete our final assignment in this class, where we're looking at test scores between three teachers' classes and um, how many periods they missed within that class. In order to make sure that we can adjust our means to determine whether there is a difference in means without a confounding variable, we're going to run an ANCOVA, hold which will let us know whether or not the means are affected by the periods missed and basically allow us to compare apples to apples. The first thing that we're going to do, of course, is determine whether we have normal data. And we'll do that by analyzing. First, let's set our null hypothesis. Our null hypothesis is that there is not a difference in the means of the three groups of students taught by the three different teachers. Our alternative hypothesis is that there is a difference. So first we're going to look at normality, and we'll do that by going to descriptive statistics and explore. Our dependent variable is our test scores, and our independent variable is the class. And we're going to look at that. We'll hit plots. We've unchecked the stem and leaf and checked the histogram, and we're looking at normality plots with a test curve. And we'll hit continue. And then we're looking at both, so we'll hit OK. So now we can look at whether or not these data appear normal. The first thing that we'll review is our Shapiro-Wilk test. And we can see here we have a test score of 0.984 for Miss Smith's class with 30 degrees of freedom and a significance value of 0.927, which is not significant. And we can see that all other data groups follow suit. So we do assume normality here. Our histograms can validate that. So if we review our histograms, they do all look fairly normal. And so that's our first assumption checked. The second thing that we want to check is our homogeneity of regression. And we're going to check that by plotting the points first. So we'll go to graphs and scatter dot, and we'll go to a simple scatter, define. We've already have some of our things moved over here, but basically we're going to put the dependent value on the y-axis, the covariant value on the x-axis, and the independent value on set markers, which should give us a scatter plot. And we'll hit OK. And scroll down and look at our scatter plot. Now, just looking at the scatter plot, I would be concerned as to whether we have homogeneity of regression slopes here. I can't really tell by looking. So we're going to actually run a statistical number that will tell us whether or not we meet homogeneity here. And to do that, we're going to go to Analyze and General Linear Model, Univariate. We already have these in here, but we are putting our dependent variable here in dependent variable, our fixed factor, which is our independent variable, fixed factor, and our covariant here in covariant. And then we're going to hit model. In model, we're going to go to build custom terms. I'll take one of these out so you can see kind of how this works. So we can pretend we already moved class over. So we'll take the P missed value, bring it down, and add it to our model. And then we want to take our class value and multiply it times our P missed value. And we're going to add that to our model as well. And then hit continue. Once we have that in, we're looking for a line that goes in those plots so that that we can look at our homogeneity of regression slopes. We're going to hit OK. And we should see now a univariate analysis of variance. And here we are looking at this value here. So we're looking for our class times P missed, for which we have a tested p-value of 0.488. And because that is greater than 0.05, we can say that we can assume that homogeneity of regression slopes is met. So we have looked at our normality, we've looked at our homogeneity of regression. So now we can go ahead and run our ANCOVA, because in running our ANCOVA, we'll check our last assumption, which is the Levine's test. The ANCOVA, running the ANCOVA looks very similar to looking at homogeneity of regression slopes. So we're going to come back to the analyze, general linear model and hit univariate. We already have these factors in. We're going to leave them right where they are and go to model. We're no longer going to build custom terms, but go to full factorial and hit continue. We want to do some other things here. So we're going to go to EM means. And we're going to display our means for class because that's our independent variable. We want to hit compare main effects. And we want our confidence interval adjustments to be Bonferroni. And these will give us some additional information. And hit continue. We also want to go into options because we want to choose some different things that we want to display. So we'll be looking at our descriptive statistics, our estimates of effect size, and our homogeneity test. This will give us our Levine's value that we need to look at before we can look at our results for the ANCOVA. And we'll hit continue. So we've looked at all of our options. So we're going to go ahead and hit OK, and our ANCOVA should run. Okay, so our descriptive statistics, we have 30 students in each group. These are our means, but not our adjusted means. We'll look at our adjusted means if there are things that we need to look at there. We can check our Levine. So this is our homogeneity of variances, and we can see that we have a p-value of 0.691, which is higher than 0.05. So we would say this is not significant, meaning we do have homogeneity of variances. So then we can go down and look at our ANCOVA results. The line that we're going to look at here is the class line because that's our independent value. And we can see that we have a test statistic of with 2 degrees of freedom of 4.116. And we have a p-value of 0.020, which tells us that holding steady for classes missed or periods missed, we still see a significant difference in between the values of these 3 different classes. Because we have a significant value here, we can go down and look at number 1, our adjusted means. So we have our adjusted means here, and these means just hold steady for classes missed. So that we're comparing apples to apples between the 3 classes. We can also look at our pairwise comparisons. Remember that the ANCOVA will tell us if there is an effect. The pairwise comparisons tell us where that effect is. So between Smith and Jones, we have a significant value. So there is a significant difference between the test scores of Smith and Jones. There is not a significant difference, so we would fail to reject the null hypothesis between Smith and Brown. And between Jones and Brown, we also see no significant difference. The last thing that we're going to want to look at is the effect size here. So if we scroll back up to where we looked at our ANCOVA results, we'll see our partial eta squared. And we can look at this line for class, and we see that we have a partial eta squared of 0.087. In general, this would indicate a medium effect size. And that will conclude how we run an ANCOVA. In this case, one last thing. In this case, we do fail to reject the null hypothesis, and we go with the alternative hypothesis that there is a difference between these test scores. And that will conclude this.